Hello students, this is Thiraviaselvi, Assistant Professor at Department of Artificial Intelligence and Machine Learning, St. Joseph College of Engineering, Chennai. And in this video, I'm going to teach you computer networks. And computer networks consist of n number of topics. Among them, I'm going to teach OSI layers. It's already known to everyone. I'm going to give a simplified view of OSI layers. And first of all, let me explain you what is OSI. And OSI stands for Open Systems Interconnection. That is how to interconnect the different systems through different layers and how can we make communications in a smoother way from sender to receive. Okay, and this OSI layer is approved by ISO. And here, this OSI layer consists of 7 functional layers. It consists of 7 functional layers. So, from the name itself, it is understood that we cannot see or segregate these 7 layers, but they are functionally segregated. And now, let me write down all the 7 layers. Then, I will teach you one after the other the detailed representation of each layer. The first layer is called application layer or topmost layer. The next one is called presentation layer. Third one is session layer. Fourth one is transport layer. The next one is network layer. Next one is data link layer. The last one is physical layer. So I told you that we have 7 layers. This is the topmost layer. This is the bottommost layer. Topmost layer deals with application. The next one presentation. The next one session. The next transport. The next one network. And the next one is data link layer. The last one is the physical layer. And while sending, that is when you consider the sender, you will be having applications here. Your application will be of any format. It may be a video, it may be an image, or it may be alphanumeric, whatever it may. The applications will be of different format. So your data are available in this layer. And when you send the data, and it will be converted in zeros and zeros through wired or wireless network, it will be passed to the next physical layer of the receiver. So, your data will pass from top to bottom and in the receiver side, bottom to top. Now, I am going to teach you from the sender side. So, I will be considering application layer as the first layer. We can teach from the bottom also. If we consider the receiver side, we can teach from the bottom. And I am considering the sender side because the applications are well known to the user or end users, so we use the application layer. Okay, now let me tell you the gist of each layer. Afterwards, let me get into each layer. The first one is the application layer. And application denotes, as I told you already, it may be an application of, for example, it may be a YouTube video, or it may be a Word document, or it may be an image, whatever it may. So now I have told you 3 examples. One Word document, the next one video, the next one image. These 3 of different types or of different formats, and they have to pass through this entire all layers. So our responsibility is to change the format that is easy to be transmitted. That is, we all know the data are transmitted as zeros and ones, right? So this presentation layer is responsible for changing the format that is readable or understandable by the upcoming devices. Okay, this is the responsibility for this presentation layer. The next one, session layer. Session. For example, if you want to join any meeting, means someone will be the host and he will be monitoring the entire meeting, right? The session will be chaired by someone else and they will be allowing the people, they will be giving access rights to the people, they will be monitoring all the activities of the people, those who are engaged in the session, right? And they are responsible for establishing and terminating the session. The same activity will be done by this session layer. The next one, transport layer. Now everything has made ready, right? And now the data is to be sent. So that is the responsibility of this transport layer. Then what about network layer? Now we have dealt everything within the network. Now it is passing to the different networks. Actually, we know that different local networks are available and not only local, different levels of networks are available, LAN, WAN, MAN, different levels of networks. So this is responsible for transmitting your data from one network to another network. Then what about this data link layer? This data link layer is responsible for medium access. And what is that medium? Medium in the sense, and one medium will be available, everyone will be accessing that medium. Just like that, a road will be available, we all will be using that. But without collision, we have to travel, right? The same way, all the devices will be connected in the same medium. And all the devices will be communicating between different devices. So in these scenarios, what it should be done? There should be no collision. There should be no congestion. So for that, what should be done? The medium must be accessed in a sequential or automatical and well disciplined manner. So that is managed by this layer. The next one, physical layer. From the name itself, it is understood. It deals with bits, volts, amplification, wires, and the properties of hardware, and everything is dealt here. So these are the 7 functional layers. I have incorporated all the important details about these layers. Now I'm going to explain briefly about each layer one by one. Now let me tell you about the application layer. So consider this. So from the name, application itself, it is understood that this layer is dealing with application. And applications are of different type. And each application is having its own format. Okay. So here my information is called data. Okay. Then what are the protocols I will be using in this layer? Protocol means it's a procedure. So each application will be having its own format. So the procedures are changing while sending the data. So we have n number of protocols in this layer. Let me tell you only few examples. So the protocols available here are FTP, HTTP, Telnet, and etc. N number of protocols are available. So I have told you what is the nomenclature that we use here is data. Next, different number of protocols available. And this application layer will forward the data to this presentation layer. And what is the functionality of presentation layer means? Here the data is transferred directly to this presentation layer. So in the application layer, we have applications and we have the data, and these data are converted into one format in the presentation layer. That is the functionality of presentation layer. For this, these protocols are used, and we can have few more protocols also. For example, I have written only few. Okay, this is about application. Then what about presentation layer? Presentation. Presentation, I already told you, this is responsible for formatting. Okay. responsible for formatting in the sense three major functionalities are available here. Now let me tell you the real responsibility of presentation layer. Here your information is again called data, and here what are the functionalities in the sense it is given as data translation, data compression, encryption or decryption. Let me explain each one of the terms individually. Okay. First one, data translation. From the name itself, it is identified. It is responsible for translating the format of your data. So your format is, it may be video, audio, or alphanumeric. That those and all are converted into zeros and ones. Okay, ma? Likewise, all the data are converted into zeros and ones. And next, we have to send the data. If we want to send, we have to reduce the size for efficiency because it will be consuming more time and it will be occupying the entire network. So, automatically the efficiency will get reduced. So, for that what we can do? We can compress. So, compress in the sense my data may change. You may think that, but that is not the case. We have two types of compression here. One is lossy, the next one lossless. Lossy means some amount of data may be reduced or get lost. Lossless means no much amount of data will be lost. Then when reconstructing at the receiver side, will be reconstructing to bring back to it the original form. This lossy compression will be missing some data, that is the quality of data will get reduced. Here in lossless compression, when you reconstruct, the quality will be retained as it is. So this is the difference between these two data, these two types of compression. Okay. Next, encryption or decryption. Encryption, whenever you send the data, that data must be covered. That is, that should not be known, that should not be available to anyone other than sender and the receiver. So to ensure that, we use many more technologies. That technologies are called encryption. If you apply that mechanism in the sender side, we call it as encryption. If you apply that mechanism in the receiver side in reverse order, then it is called decryption. So for encryption and decryption, we use one protocol that is called SSL, that is Secure Sockets Layer. Listen, so here I have explained you about the different functionalities of this presentation layer. We call the information as data and we use the protocol, example protocol is SSL, and it has three functionalities: data translation, data compression, and encryption or decryption. Translation is converting the format. So we call this layer as the gateway because it is responsible for all the formats. The next one, data compression, that helps in sending the data efficiently. Next, encryption for hiding the data. Okay, these are all the three functionalities of this presentation layer. Next, we are getting into the next layer, that is session layer. Let's see. about session layer. As I told you, when you are going into any session, the session will be starting, the session will be ending. In between, some people will be managing and organizing, right? The same activity will be done by this session layer. Okay, here we call our information as data, and it's responsible for all the remote activity. So we use the protocol remote procedure call. We use the protocol remote procedure call, and the session layer is responsible for the people, those who are available inside. In real world, they are called people. In computer world, it may be files, it may be devices, or it may be some entities. Okay, and it is responsible for synchronization. It's responsible for synchronization. It must synchronize the clock signal of the other devices that are engaged in that network. Okay, and first of all, it is responsible for authentication. Next, for authorization. Third one is dialogue control. Authentication in the sense, the normal meaning. So it will be allowing only the people, those who are intended to be here. It will check who you are, that is, who the sender is, from whom the data is received. That check is done here. Next, authorization. What are all the access rights given to that particular sender or particular file or particular entities? Okay. First, authentication. Next, authorization. The entire session control. That is dialogue control. It is responsible for, already told you, it is responsible for synchronization. And here we can have one more point, that is checkpoint. Throughout the entire session, it will be having many checkpoints in between. If there is any portion get lost, it will go back to that checkpoint and redo from there. So that is a error control mechanism here, like we can say like that. So these are the three main responsibilities of this session layer. The synchronization is synchronizing the clock signals of different devices engaged in that network. Okay. The next one is about transport layer. Okay, so I have taught you about three different layers thus far, and now we are going to learn about transport layer. We used to consider these three layers as main layers of this OSI layers, because these functionalities will take only few seconds of time, and but this would take more time relatively uh, compared to these layers. Okay, and now let me teach you about transport layer. So from the name transport itself, it is understood what is the functionality of this transport layer. And here, what is the name for our information? The name for our information here is segments. And so far, the name for our information is data. Here also it is called data, here also it is called data, here also it is called data. Now, the data is converted into segment. Okay. Now, and what are the components of this segments means different components are available. For our study, we are taking only two important component. One is sequence number. The next one is port number. Okay, sequence number, in the sense it will be marking the order of the segments, and what is the order, and it should be following one sequence, and we have to consider the segments according to the sequence number. The next one, port number. Port number is usually assigned to different applications, and each application will be having its own port number. So to identify the segments to send to which application, we use this port number. Sequence number is to consolidate the segments. If the sequence number 124 belongs to a particular number 4, port number 4 means, then the 4 sequence of segments will be passed to that particular application. Now let us learn about the protocols that is to be learned in this layer, and it has two main protocols, TCP and UDP. What does mean by TCP? TCP stands for Transmission Control Protocol. UDP stands for User Datagram Protocol. What is the difference between these two protocols? TCP and UDP means this is connection oriented, this is connectionless. Connection oriented, connectionless. What is the main difference between these two? So this protocol uses a connection. This protocol never uses a connection. That means before sending the data, it will establish a connection between the sender to the receiver. Okay? And after establishing that connection, it will be sending the data. Once the data sending over, the connection will be terminated. So this protocol consumes more time or spends its time in establishing and terminating this connection. Here, this protocol never made a connection. That is, if you have 10 packets or 10 segments means, and each segment will find its own way and travel to the network. Segment 1 may be reached at different time, and it may be reached after segment 2, and it may be reached after segment 10 also. There will be no order here. So if all the segments are received, then the data is correct. If the segment is lost, there is no retransmission mechanism to here. But here you have sequence and all will be sent in the same sequential order. So it is more secured when compared to this one. So that is why we call it as connection oriented and connectionless. And we'll be teaching it, we'll be learning all those things, its header and its formats, everything will be learned in different subtopics. Okay, now you know the difference between these two protocols. Now let us come to the portion of this functionality. And what is the main functionality of this layer? The main functionalities in the sense we can call error control and flow control. What is mean by error? So from here itself it is understood that data you are sending are of bits. Okay. If there is any damage in the segment or if there any segment get lost, then that is an error. How can we control those things? What about flow control? Flow, that is, it must be high or low. What is that word flow means? That is the transmission of data here. The flow denotes transmission of data. Then how can we control this? For example, you are having a device that is called server. Okay, consider this as a server and it has a speed of 100 Mbps. And consider a mobile, this has a speed of 10 Mbps. And both has a connection and they have to communicate with each other for data transfer. So, relatively this is faster than this. So, in this scenario, obviously you will get into congestion, collision, and these will make your segment to be damaged or get lost. So, there should be a mechanism for this to get it sent in a proper way. That mechanisms comes under the name flow control. Okay. Next, error control. What is mean by this error control? If a flow is not controlled properly, obviously it will have some error that will lead to segment damage or segment loss. Then how can we control this? Shall we remake the segment? No. Here they use one technique called, two techniques are used. One is ARQ, automatic repeat request. The next one is checksum. Call it as automatic repeat request. The next one checksum. Automatic repeat. Repeat means the sending is repeated. So while the receiver finds that the segments numbers all from 0 to 10 are received except 9, that means 9 is lost. Then it will ask the sender through some acknowledgements or negative acknowledgements or some other packet signals. It will ask the sender for resending the packet. And for that we have n number of mechanisms. It may be sending that particular segment 9 alone or all other segments also. That depends upon the mechanism the network follows. The next one, check sum. Sum, we have to check the sum. That is, one particular number will be added to all the segments at one portion. And on the receiver side, these numbers will be summed up, that is added up, and it will bring back one value. That value will be matched with the code sent by the sender. If that is matched, all the packets are received as it is without any damage or any masquerade or any attack. That is, in the error control mechanism, we have two methods. One is automatic repeat request. That is, the request will be given by the sender. Request will be given by the receiver to the sender. The sender will be sending the segment. Either it will be sending the lost segment or the all the segments. The next mechanism is checksum. That is, a particular value will be appended to each segment. At the receiver side, that values will be added up and the final value will be compared with the value code word sent by the sender. If both the values are same, then all the segments will be accepted, or else they have to go through another one repeat request. Okay, these are the two functions of this transport layer. So let me explain you again the gist of this. We call them as segment, and it is considered it has n number of functionalities. So we have to take in these two numbers, sequence number and port number. Sequence number is for ordering the segments and port number is to find to which application the segment belongs to. The next one, the protocols available here, TCP and UDP, transmission control protocol, and UDP. User datagram protocol. This is connection oriented, this is connectionless. This is typically faster when compared to TCP. And here we have two major functions, error control and flow control. Error control means ARQ and checksum. Flow control means controlling the flow by adjusting the speed. It may be increasing the speed of this device, it may be reducing the speed of this device. Anyhow, they have to adjust themselves to have a better flow control to avoid the congestion. So this is all about transport layer. Now we are getting into this network layer. Now let us learn about this network layer. Understand this word, network, that is, and before this we never had this word. Now we have network, that is to make communication between two different networks. You all know We have n number of networks, LAN, WAN, MAN, PAN, different number of networks are there. So thus far we had all our activities within the same network. If your sender or receiver in the same network. So within the network, it's applicable. But when your receiver is away from your network, you have to pass through different networks, right? In that scenario, network layer plays a vital role. And here, we call our data as packets. Okay. Then, as usual, what is the protocol we use here? We use IP. That is Inter-Networking Protocol. Inter-Networking Protocol uses one address called IP address. It's otherwise called logical address. Okay. So here the data is considered as packets and the protocol mainly used here is Inter-Networking Protocol, and here we use one address called IP address. We call it as a logical address, something logical, not physical. Okay, we have physical address too, that is in the next layer. We'll come to that later. Okay, and this logical address, and this is a very huge or big topic, and that we have to deal in a different video. And before that, let me tell you what is the main function here is. Main function is routing. You can call it as routing or routing, that's up to you. And routing in the sense, you have to find the route between the sender and the receiver across the network, that is over the network. You may be passing more than one network in between, and over the network you have to find the route. So route finding means you have to use one algorithm to find the best route. Okay, here you will be incorporating routing algorithms. Okay, n number of algorithms are available, and researchers are still going on to reduce the delay, to reduce the memory, and so many algorithms are there. So the main logic or concept here is routing. Here people do find route and send the data from one network to another network. So that is the main responsibility of this layer. This inter-networking protocol uses different types of addresses too. An IP address, each and every computer will be having a IP address, and this IP address are of two types. It is static and dynamic, and in other way we can call it as private and public, and in versions we can call it as version 4 and version 6. So different number of concepts and header formats are available. So we need a different video to explain all these concepts. So this is all about different layers of computer networks. So I am dealing only with the IP address and the main functionality of this. Here the main functionality is routing. So this routing incorporates many routing algorithms, and here we have coined the term packet. Okay, so this is all about this network layer. So the next layer is data link layer. Now we have transferred the data across the network, and we have to reach the particular device, and we have sent the data to the device. Now we have to send the data to the particular app or an application. Now we are coming into this data link layer, and what is the responsibility and what is the name of the data in this layer? Let us see. Let's learn about this data link layer. This layer is responsible for switching. Here the data is called frame. In the previous layer it was called packet. The device we had here is router, and the device we have here is switch. Okay, and here it has two major layers. The first one is logical link control. The next one, medium access control. Now, here the data is transferred from one network to another network. That is one router to another router. And from that router, it must reach a switch. And the switch will be connecting devices within that network. Okay. Now, for that purpose, we use this layer, this medium access control. And this is useful for accessing the medium in a controlled way. For example, in a four-way, we can have only 4 cars at a time. But if you have more than 4, and they will be colliding with each other. Likewise, here, according to the medium capacity, the devices will be allowed to access the medium. So that control is main functionality of this layer, and we have one address called MAC address. That is called physical address. I already told you about logical address. If there is something logical, there must be something physical. This address is available in all the devices during its manufacturing time itself. Okay. Then logical link control means to make these frames together and control the link and to do extra error and flow control. Error and flow control, that is within network. Okay. Extra error and flow control will also be done by this data link layer, mainly by this logical link control. So medium access control is making use of MAC address, and it helps in accessing the medium in such a way that there must be no collision or congestion. And here the links will be controlled through error and flow control. And what is the protocol we have here? That is Ethernet. What do you mean by Ethernet? Technically we call it as IEEE 802.3. Okay. So this is the protocol that we use. This is not only the single protocol we use. Many more protocols are available. This is already known to you. That is why I have listed here. Okay. So this is all about this data link layer. This is something important when compared to all the above previous 3 layers, because here the name is packet, here the name is frame, here the name is segment. Here the name is data. So from the name itself we can identify the differentiation between these 3 layers. These are the 3 important layers of these 7 layers. Okay. So this data link layer, this is called frame. Here the functionality is switching. Here the functionality is routing, and here we have 2 sub layers, and these layers are responsible for their own functionalities. Now I have to teach you physical layer. The physical, from the name itself it is identified. What is physical? Physical, that is bits. So here the data are given as bits, and it is responsible for hardware, wire, wireless in the communications. All these communications and hardware oriented components are taken care of here. Here what type of cable we use? It is coaxial. Likewise, the basic the physical device oriented, hardware oriented things are taken care of here. So this is all about 7 layers of computer networks. The first one, application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So I am teaching from the point of sender. that is from top to bottom, and someone may teach from bottom to top. Both are similar, but this is already known to you, right? The applications are known, so that is why I have started from here. So it is converted into the format that is needed for the devices, and the session is entire session must be controlled so that no one can interfere. That must be some case security here. Then it is transported using TCP or UDP. Next, it is forwarded to other network, and from there, from the router, it will be forwarded to the switch, and from the switch, it will be forwarded to the repeaters. So I can write the different devices used here are, here we will be using repeater. Okay, you know the functionality of repeater. Then here the interconnecting device is switch. Here it is router. These are the three main devices we need, and they will be used as a interfaces between these layers. And then last or topmost layer will be having hub that will be acting as a gateway. The same number of interfacing devices are used in between. So these are the logical or functional explanations of this OSI layer. So I have given you the gist and a brief detail about the 7 layers. So we know the functionalities, the protocols, and the data formats of these layers. Okay. So okay, we'll meet you in the next video in some other topic. Thank you so much.